Good afternoon, everyone. I'm Sanket, and I'll be presenting our work on defining an access control framework for the augmented reality systems. And as if my previous speakers did not do a great job at explaining what augmented reality systems are, let me give another shot. So today, augmented reality systems or mixed reality systems are being developed with one of two defining form factors. You either have these standalone devices where the sensors, the computation unit, and the display unit are all packaged onto the same device. Or you have them as with a companion device where they provide you with heads-up display units which you can tether with your smartphone and use your smartphone to offload all the computational tasks. But irrespective of what design strategy they use, the functionality remains pretty much the same. You have a bunch of device sensors which provide information about the user's environmental context. These applications derive that information from the sensors, and based on that information, they create some kind of visual artifact which then gets projected onto the user's display screen. But similar to their mobile counterparts, these applications remain widely untrustworthy. So let's look at how these applications are built in the first place. If you are a developer and you want to build an augmented reality or a mixed reality application, you choose one of these development frameworks like Unity, let's say. Now, Unity depends on some SDK libraries like ARCore from Google or ARKit from Apple to be able to interface with the target system for like Android devices or iOS devices. Now, the benefit that these SDK libraries provide is that they allow developers to use very high-level APIs to extract abstract information as opposed to reading the sensors directly and processing the information themselves. Now, since the applications extract high-level functional information, the target sensor access is actually implemented by the Android or the iOS platforms. Now, this is where it creates this dichotomy between the data, what kind of data is required, and how the sensor access is handled. To further clarify this, we looked at 17 devices from different manufacturers and how, as a developer, if you want to publish your application for one of these devices, how do you go about defining what sensor data you need? It turns out almost all of these devices use some variation of the smartphone operating system model, which, as it turns out in most cases, is the Android app manifest file, which is a very coarse-grained structure of defining access control decisions. Now, this is where the problem arises. Let's walk through an example here. Here is an application from Google Play Store, an AR application, where the developer has clearly specified a specific use case for accessing the camera sensor. The developer says that they need camera sensor to recognize artworks, and that's the functionality of this application. Now, when the user installs this application on their phone, the user gets a system prompt saying that this app has requested access to your camera sensor. User grants the permission to the application on first use, and now this application has full access to the data from the camera sensor. Now, even though the application's functional use case is just object detection, it has it retains complete access to camera sensor because the way the Android's permission model is defined. And this creates the classic case of an overprivileged system where a malicious user could pretend to the user that it's only using the object detection API, but instead can use something way more privacy sensitive like the face detection APIs and track users' faces from users' environment. And the root of this problem is the granularity at which platforms like Android implement their access control decisions. So what can we do about it? Well, thankfully, today we stand at a turning point where organizations like Apple are trying to push forward a specific purpose operating system for their augmented reality devices. Apple's Vision OS is the first such example of having a dedicated OS just for augmented reality systems. So as these kind of operating systems become more popular and become more mainstream, we stand today to ask ourselves the questions, can we reimagine how access control could be done for these systems? Towards that effort, we identify 3 questions from a research point of view. First, how can we regulate direct access to sensors? Second, how do we ensure a least privilege access control model that allows developers to specify what their requirements are and allow the system to enforce or provide access based on those specific requirements and nothing more? And finally, can we allow users to have the flexibility to adjust the access control based on their own preferences? We envision Erebus as a system that allows regulating access to sensor information at the operating system level. As specific purpose OSs become more mainstream, it is only natural that libraries, SDK libraries like ARCore and ARKit become integrated into the operating system. There are not only performance benefits of making such a move by reducing a lot of the library code from the application, but also allows the system to have more visibility into what kind of APIs the app is requesting access to. We designed Erebus with that kind of a hypothesis that we can enforce access control rules at the OS level. Further, we also designed a policy specification language that allows developers to express the exact functional requirement of their application. Consider the example from earlier. Here, the developer specified that their functional requirement is to recognize artworks, but because of the limitations of current systems, they request access to camera. With Erebus, we provide developers with a framework where the functional description can be conveyed to the system in a form of a semi-structured natural language format. And the system converts this policy into enforcement that it can enforce at the system level at runtime. And because of the way the policy language is structured, it also allows us the ability to define what sensors are requested access to, what data is requested access to, where it can be accessed, and when it can be accessed. For example, in this case, the user has the ability to restrict an app's access to particular APIs or particular information only when they are home or only when they are only during the evening. This further ensures that we abide by the least privilege policies that we claim to have in our system. But that is not all. If we are if you're trying to regulate access to apps access to sensor data at the system level, there is a possibility that the system could leak potentially privacy-sensitive information to the application. This is particularly challenging in the case of object detection, where an app wants to detect a specific kind of object from the camera view. Now, in this case, for example, the app should receive the object marked in blue, which is like my hotel key card, but not my driving license information. So how do we prevent this in the first place at the system level? Now, object detection on mobile systems, at least currently, is an imperfect process. We cannot guarantee 100% accuracy in detecting objects. Towards that effort, we leverage a technique within Erebus. We leverage a technique called conflation, where we try to increase the object detection accuracy of the model by running object detection on multiple frames and then passing the object with high detection accuracy to the application. Now, this implementation is definitely not perfect, but as systems become more powerful and mobile systems become more powerful and on-device object detection algorithms become better, the accuracy of detecting objects is only going to get better. Now, Erebus is designed as a framework for developers to build AR applications. So there are some obvious questions that developers will have when trying to implement Erebus for their use cases. First of which is, will it affect the latency of my API calls that I'm making to the system? Now, we built some prototype applications and ran some latency measurements, and we found that because Erebus runs the rule enforcement at runtime before making API calls, there is a certain overhead that we incur, but it does not affect the overall performance of the application. In fact, when we looked at all the different components that an application has and looked at the latency measurements for all the different components, we found that Erebus combined, the latency overhead of Erebus components combined, is still lesser than a lot of the latency incurred due to system implementation like GPU readback. So as mobile systems become more powerful, the performance of AR applications on our systems is only going to get better, even with something like Erebus, which performs runtime rule checking and the latency overheads because of that. Furthermore, we found that all of our prototype applications that we developed were able to run at nearly 35 FPS, even with all the permission checking happening. Finally, to demonstrate how our framework can be adapted, we implemented our entire framework using the Google ARCore SDK file, Google ARCore SDK, and we developed 5 prototype applications using the Unity framework. Now, these prototype applications reflect the large majority of applications that we surveyed currently on Play Store and Apple's App Store. And we open source our framework implementation, the policy language design, and prototype applications for reference and for future research. Our artifacts have received all the functional and reproducible batches through the artifact evaluation process as well. Now, in summary, we were interested to look how AR applications are being developed for augmented reality systems. When we started looking at the development frameworks and the access control frameworks, we found clear inconsistencies between them. With Erebus, we try to pitch access control framework that can be adapted today by developers to build AR applications with the promises of a least privilege access control model. That'll be all. If you have any other questions, I'll be happy to take them, or if you can refer to our paper.